When I started looking for macroscopic trace evidence of wheel techniques in potting in 2007, Professor Karl Nappet gave me the opportunity to travel to East Crete and work during the post-excavation season at Palicastro. I spent about 2.5 months getting accustomed to the pottery from the site, while also seeing a range of different types of traces and forming a few hypotheses about those traces. The conversations I had with Karl were absolutely instrumental in gaining familiarity with the traces I was seeing on the material, and those first few months at Palicastro made an enormous difference in the course of my research. But while I was really fortunate to have this one-on-one and in-person artifact study to establish a foundation for my subsequent work, it's important that we recognize these opportunities are not open to everyone who might wish to have them. Indeed, we've seen over the past few months that in-person physical examination of artifacts is not guaranteed. In the years since that summer, I've spoken with a lot of people about my findings, the material they're studying, and the field in general, and I've come to see 3 main barriers to participation in assessment of wheel potting and assemblages. Those are experience, access to comparative material, and the qualities of accessible comparative material. Today, I'll be discussing some of the ways I've tried to dismantle those barriers. I'll also be introducing some of the recent work I've done, along with my colleagues Jill Hilditch and Loes Ofkenhafen of the Tracing the Potter's Wheel project, in order to further widen accessibility. It's useful to start out with a bit more detail about the nature of those barriers to participation, however. It's necessary to gain experience in order to reliably identify and discuss the techniques and methods of potting which were practiced on the wheel. This experience can come from 2 complementary sources: the collaborative study of archaeological and experimental material, and the completion of experimental archaeology hypothesis testing. Collaborative study is a foundation of material specialization in archaeology, where an individual or group handle material under the supervision and guidance of a material specialist, forming an apprenticeship of sorts. By having this hands-on time building up experience with discovering and understanding the trace evidence for wheel potting, young scholars gain independence and confidence to apply that understanding in their future study. This is true regardless of whether they build this experience using experimental or archaeological material. So what makes this a barrier to participation? The small group or one-on-one model of gaining this experience is a bottleneck which limits the number of potential students. There's also a limited amount of time that any scholar has to invest in this kind of training over the course of a study season or academic year, and inclusion in these groups is often based on professional contact networks. The net effect of this is a restriction of the number of opportunities for participation. Completion of experiments is restricted in a different way. A young scholar must either develop a relationship with an experienced potter to produce material, or they must rely on completing experiments themselves, after gaining the skills necessary to do so. Working with an experienced potter has similar difficulties to collaborative study, with the added dimension of financial costs for compensating the participating potter. If young scholars are to complete the experiments themselves, they must first invest time to gain the potting skills, or else rely on pre-existing skills, which are barriers in and of themselves. Access to comparative material further limits participation in the type of analysis at the heart of this conference. By comparative material, I mean either archaeological and experimental, which acts as a reference during the first-hand examination of new archaeological material, as well as during analysis and interpretation. Comparative material need not exclusively take the form of the physical objects themselves. Publications are an excellent source of comparative material for many existing specialists. In my experience, however, publications do not often adequately communicate the morphology of trace evidence indicative of wheel potting. Not all comparative material is equally relevant. The variable nature and the characteristic qualities of the comparative material, which can be used for reference during analysis and interpretation of archaeological material, produces similarly variable results. Unlike comparative material for vessel morphology or decoration, the presentation of comparative material for technological assessment is still developing. High-quality images and detailed illustrations are increasingly common, but are still not standardized in the field. Characteristics such as the vessel morphology and their raw materials play an important role in how appropriate it is to draw conclusions based on that comparison. Furthermore, and especially in the case of experimental material, the application of specific types of forming has a significant impact on the relevance of that comparison. In addition to investigating the practices in use during the Bronze Age in a number of East Mediterranean contexts, the work that I have completed has increasingly served to remove these barriers to participation in assessing wheel potting practices. These efforts generally fall into two categories: refining low-cost and low-tech methods of study, and creating experimental typesets with broad applicability. The low-tech and low-cost methods I employ for identifying and communicating forming techniques are based on a simple analytical method, the macroscopic assessment of surface traces. While for a precise understanding of the chaîne opératoire, scholars are strongly advised to use complementary analytical techniques, I focus solely on macroscopic surface traces in order to develop methods which are easily integrated into earlier stages of post-excavation processing. Normalizing these practices will lead to higher quality forming assessments in artifact catalogs, which in turn can push this particular corner of archaeology further, and we can better concentrate our efforts on detailed studies. It also means that we can start seeing the broader picture of technological change through time right in the source, the excavation reports which feature extensive artifact catalogs. My hope is that a basic understanding of pottery production practices becomes common enough that it is just another attribute recorded in the normal course of creating artifact catalogs, much like descriptions of fabric characteristics have done. In order to capture macroscopic surface traces, I use a DSLR, a small tripod, a flashlight, some Lego bricks, and a light-restricting photo box made of binders, clips, and black fabric. I prop the sherd or pot in a stable position using the Lego bricks hidden under the black fabric. By shining light across the sherd surface from different angles, I can highlight the presence and morphology of surface traces. These images serve to clearly represent what is visible to the naked eye during in-person study, which produces higher quality comparative resources. As an experimental archaeologist, there are a number of difficult decisions to make before hypothesis testing can begin. My experiments focus on forming a typeset of vessels using wheel coiling as well as wheel throwing in order to produce vessels against which archaeological material can be compared. There are different ways to approach this type of experiment. You might precisely mirror the morphological representation of one or more specific vessel types and clay types, and then compare against those specific shapes in the archaeological record. At the other extreme, you might create one or more basic shapes using one clay type, leading to broader but less specific assessments about a wider swath of the archaeological assemblage. There are benefits and drawbacks to each approach. My strategy has been to negotiate a middle path. I focus on experiment through generalized typesets. Within the experiments I have conducted, a generalized typeset focuses on representative geometric features of vessels by visualizing vessels in terms of different zones. My typeset captures differences which may appear in 3 different zones: floor to lower wall angle, the mid-wall curvature, and the upper wall to rim inflection. These differing zones are subject to specific kinds of stresses during the overall potting process, either with or without rotation. The stresses imposed on a convex profile versus a concave profile, for example, may result in different kinds of forming traces. While a generalized typeset may not perfectly represent every wheel-formed vessel found at late Bronze Age Telos, for example, it does allow for a modular perspective to be taken. Many traces on the archaeological material are clarified, and a basic wheel-forming technology assessment is possible. This approach leaves fewer open questions after this quote-unquote first pass, and precise investigation of shape representation can be pursued on a case-by-case basis. I've created 2 different generalized typesets, and at this point it's instructive to discuss a few of the particulars relating to each. My PhD research was the first opportunity to create a generalized typeset. In that research, I studied the earliest wide-scale application of rotational potting in both Crete and Cyprus. For Crete, this covered Middle Minoan 1b through Late Minoan 1a, while for Cyprus it covered Late Cypriot 1 through Late Cypriot 2b. The ceramics representative of these 2 islands during these periods were by no means homogeneous, so it was clear that I would need to find a way to maximize my experimental efforts. Thus, the generalized typeset was born, allowing me to assess the different macroscopic traces for specific methods of wheel coiling, described by Roux and Corti. The typeset was formed of untempered, commercially available clay and represented 8 different shapes and 3 different wheel coiling methods. The 24 distinct combinations of forming method and vessel shape were repeated 5 times, and the potting process for each was recorded on video from the side. In an effort to widen access to this work, I've divided the whole typeset into representative samples, each of which has the 24 combinations of forming method and vessel shape. As of today, 3 of the representative samples are kept by different universities. I also have a personal collection. Aside from being physically available for study, the typeset is featured in UMR 7055's online study collections database, and it has served as a teaching aid in guest lectures, workshops, and research visits by myself and other scholars, and the potting process videos are available on my YouTube channel. In my role here in Amsterdam, with the Tracing the Potter's Wheel project, I had the opportunity to further investigate common variables while better accommodating the needs of my colleagues on the project. The typeset for this project featured a different variation on coil attachment from the PhD typeset and explored the differences between method 3 wheel coiling and the wheel throwing technique. Additionally, the focus was on comparing the differences between tempered and untempered clay. The TPW typeset was formed of commercially available clays, one tempered with 2.0mm grog and another untempered. 5 shapes were included, and those shapes were formed using either the wedged coil attachment as part of the wheel coiling method 3 or the wheel throwing technique. In total, the variables of 2 clay types, 2 forming strategies, and 5 vessel shapes produced 20 unique combinations represented within the typeset. 5 examples of each combination were created, 4 of which were vertically bisected for later analysis and recording. Like the PhD typeset, this collection can be divided into smaller representative study sets for distribution into teaching collections, but for now they will remain at the University of Amsterdam, at least until the completion of the project. I'd like to take a moment, now that I've introduced some of the experimental work that I've done, to address the question of what can be done collaboratively to remove participation of barriers of technological assessment of wheel potting practices. The single most important change that's necessary for this is for us to make more of our primary data, not just our interpretations of that data, open access. Tracing the Potter's Wheel has worked to create and host a modern, interactive database to meet this need. The experimental potting that I completed for the project is shared on this platform in several formats. Text records describe clays used, forming processes, vessel processing and firing, as well as noting which forming traces are observed. Controlled light photographs are presented showing vessel surfaces from all angles. There are also video recordings which capture the potting process from 1 to 2 angles. Finally, 3D visualizations of the pots are presented, allowing database users to interact with the models and investigate the captured traces interactively. The creation of a dedicated and open access database for the project is not the only major asset worth highlighting here. What is worthy of more attention, particularly for those of us interested in technologically assessing wheelform ceramics, is the fact that this database is open to and designed for contributions by others. TPW's work with K-Bell and Postman to create this database means that there are tested and user-friendly ways to import data from other projects. With this standardized presentation of data, cross-comparison is easier, and new datasets are readily integrated and searchable within the database. Although TPW focuses on the Aegean and the Late Bronze Age, there are no limitations on the focus of potential contributors. We will accommodate any datasets which can present more information on the nature of wheel use in the archaeological record. Beyond the action of opening the database for collaborative contributions, TPW has designed tools to make the process of collecting and sharing data simpler. One part of this is the creation of data import templates, which dictate the minimum information required for integration in the database, while also ensuring that new entries are fully integrated once they are submitted. Beyond this, TPW members have created a series of workflows which guide users through the process of data collection, covering topics such as setup and standards for controlled light photography, how to get high-quality results from even low-cost scanning equipment, and how to process 3D scans to generate high-quality visualizations. Lastly, the database features learning pathways, which are designed to orient users whether they are experienced in this kind of analysis and wish to gain more insight into using the database, or they are new to investigating early wheel use via ceramic analysis. Ultimately, the learning pathways act as a bridge between categories of users, allowing less experienced users to develop their expertise wherever they access the database. The goal in creating these tools is to increase transparency in the research process. By demonstrating the steps taken in data production and collection, others may make better use of the material presented in the database, while also reaching more meaningful interpretations when using the database as comparative material. The concept of using the database as comparative material brings this talk full circle. The main obstacles to participating in technological assessment of wheel-form ceramics, as a reminder, are experience, access to comparative material, and the qualities of the comparative material. Hands-on, in-person experience is still the de facto standard for developing specialist material skills in archaeology. But the availability of a digital study collection cultivates a new kind of hands-on material study. Individuals are able to gain familiarity with the archaeological evidence by viewing and interacting with high-quality 3D models without the associated difficulties of securing permission for study, arranging for specialist tutoring, and supporting travel to a venue where tutoring and material access are both available. The fact that the TPW database is an open-access online resource directly confronts the issue of access to comparative material. At present, a base collection is already available, composed of the vessels formed during the TPW experiments described earlier. As the project nears completion, archaeological material will also be added with the same standards. In this way, TPW has already published a body of comparative material which is tailored to the needs of wheel potting technology assessment. It can be consulted digitally during fieldwork and post-excavation analysis, just as one might refer to excavation reports for shape or decoration information. The addition of further data sets by others will only strengthen this resource. The transparency of the database in terms of data collection and presentation is a measure to overcome the final barrier to participation: qualities of the comparative material. Full documentation for existing entries and requiring the submission of key metadata on submitted collections maintains this standard of transparency so that the material presented can have greater applicability to future questions. The desired effect of these efforts, both my own and my collaboration within the Tracing the Potter's Wheel project, has been to contribute to a wider picture which is coming into increased focus. The Potter's Wheel has frequently been used as a technological identifier for any number of social phenomena, but the basis for these interpretations is successful identification of its presence. I have found that my own experience as an experimental archaeologist has given me a privileged position in tackling these questions. But the creation of an experimental typeset is a large undertaking. By actively seeking ways to maximize the applicability of that undertaking, my goal has been to free up future experimenters to focus on ever more precise questions. The ability to build on the generalized typeset is predicated on granting open access to that typeset, however. It is my hope, and the hope of my colleagues Jill and Luce in the Tracing the Potter's Wheel project, that others will take us up on the offer to build on our efforts. In return, I hope that future research projects will contribute their own material to the database, so that we will have more opportunities to push our understanding of this phenomena further. Thank you for listening.